Are you able to see my screen? So I'll unmute you guys after the demo. Okay. If you have any questions, you can just type in the questions window. I'll just respond to your questions. Okay. Fine. So let us have some discussion on Hadoop. Okay. Prior to Hadoop, you need to understand like what is big data. Okay. And then what are the solutions for processing big data. Hadoop is one of the solution. Okay. Prior to Hadoop, what were the solutions? What are the challenges or limitations? Okay, that we were facing, and how Hadoop is going to resolve them or as resolve them. Okay. So this is the agenda for today demo session. What is big data? Why you need to analyze the data? What is Hadoop and why Hadoop? Hadoop cluster, Hadoop core components, HDFS and MapReduce, and what are the other ecosystem components of Hadoop, and in which industries, okay, Hadoop is being used for its huge data processing. Okay, and then what are the various opportunities that we are having in the market on Hadoop. Okay, so any idea what is big data? What is big data? Anyone? So even if it is wrong, no problem, you can just tell me. Ram is saying more data, or Lakshmi is saying like clicks. Okay, what else? And Digo is saying large data sets, right? Big data is handling various kinds of data. Prabha is saying big data is handling. Okay. Volume, velocity. Shantanu is saying three V's. Shantanu, can you tell what are the three V's? Ankit is saying big data is unmanageable because of terabytes of data. Yeah, Prabha. Volume, velocity, and variety. Right. Okay. Fine. So most of them answered correctly, but should be like more clear. So let me give you the clarity. So big data is just a terminology. It is not any software or technology or tool. It is just a terminology representing huge data, large data sets. Okay, large in the sense it can be thousands of GBs, terabytes, petabytes, or even more than that. Generally, any data of size in terabytes or greater than terabytes, we treat it as big data. Okay. So I think you know the mathematical numbers, like 1 terabyte means 1024 gigabytes, 1 petabyte 1024 terabytes, and so on. Okay. So any data of size hundreds of GBs or more than that is generally called as big data. And in order to process that much amount of data, we use Hadoop as one of the solution. Okay. So here we are saying large data sets. What are the data sets? And what can be the data sets? So your data can exist in three forms. Your data can be structured, unstructured, and semi-structured. Your data can exist. Your big data can exist in structured, unstructured, or semi-structured format. Can someone give me example of structured data? Yeah, RDBMS tables, right? Okay, so this kind of data, you can say it as a structured data. Unstructured, In unstructured, again you're having two varieties: textual data, unstructured textual, and binary. Yeah, blogs, right? What else? Shantanu, right? Blogs is email, PDFs, docs, Word docs, Facebook, Twitter messages, etc. So any data which is not having any particular standard structure. Your structure of data can be in, okay, in different order, okay, in different formats. Fine. That is what unstructured textual. In under unstructured binary, what you are going to get? Yeah, probably you're right. Images, video files, audio files, etc. Okay. Example for semi-structure. Anyone? Did you hear about XML files? Yeah, Ram, you're right. Yeah, XML. It is like mix of structured and unstructured. For XML document, you'll have something called root tag. Under root tag, you'll have like something called child tags. Book name, price. So for each and every tag, for each and every starting tag, we need to have an ending tag. It is like mandatory. We'll be defining our schema like that. Okay. So this is like a well-defined structure. But the content that your tag can contain can be anything. It can be anything. That is the reason. It is like unstructured textual data. Fine. So that is why XML is called as a semi-structured data sets. Okay. So your big data can be structured or unstructured or semi-structured. Okay. Fine. So these are some of the sources on the internet from where huge data is being generated. YouTube. For every minute, 50 hours of video is being uploaded. Yeah, Ankit, what is your question? You're talking about XML files. This is some tag. This is some XML example I took. You're aware of XML documents? How to write XML documents? No. Okay. So you can just explore that on the internet. Okay, about XML. Okay. The only point you need to focus here is it is like a mix of structured and unstructured. So why I'm saying structured is for each and every tag, starting tag you must have ending tag. Book is having ending tag. It is a root tag for all the child tags. BN is a child tag. Price is a child tag. Okay. So in XML document, if while you're preparing XML document, you will prepare XML document like this in this format, and the content you will be placing within the child tags. Okay. So the content whatever I'm mentioning within the child tags can be unstructured or is unstructured. Okay. That is the reason it's like a mix of structured and unstructured. Hence we call it as a semi-structured document. Okay. So these are the sources which will generate the data in the internet. Google, Facebook, you know, right? So a lot of there are millions of users for Facebook. They keep uploading the photos, videos, messages, okay, etc. And Twitter, Apple receives around 50k app downloads every minute. Okay, so these are per minute, approximate numbers. These are not exact. Okay, so even it can be more than this. So if you take like a for hour for 1 week or for 1 month, you can assume how much data is being generated from these sources. Okay. And if you want to do analysis on these data sets which are being generated from these sources, you should have some good highly sophisticated system which can process this much amount of data and give the output in quick time. Okay. So Hadoop is one of the solution. Okay. Prior to Hadoop we have like RDBMS system also, like Oracle or MySQL, but we have some limitations and challenges there. What are they, we'll discuss, okay, in the next slides. So you have taken big data and you're going to give that big data as input to Hadoop or any solution, and what that solution will do. So it will process that big data and it will give the output, and from that output you can generate the reports, dashboards, scorecards. Okay. So from these dashboards, your company higher management will be able to take some decisions. For example, if you take like retail data, okay, some retail data, I mean like there is a company called Samsung company, okay, which like it produces mobiles, various brands, various models, okay, various models Samsung company will produce. Okay. So something like Galaxy Grand, S3, S5, etc. Okay. Galaxy Grand 2. So you have a lot of models. Okay. So what the company want to do is it wants to. I am just explaining the scenario where huge data is involved. Okay, and how Hadoop is being useful in processing the huge data and helping the higher management to take the better decisions. Okay, to improve the business. So there are some various models from Samsung company like Galaxy Grand S3, S5, etc. etc. Okay. So what Samsung company want is they want to find the reviews of all these models. So for that, the source is Google search, online reviews, online surveys, Facebook messages, Twitter, etc. Okay. So they collect all the information from these sources about the reviews of their models, Samsung mobile products. Okay. And from that reviews, they'll be identifying that which mobile is doing good business or which is not doing. For example, in the market, Galaxy Grand is not doing good. Sales are not good. Sales are very poor. So Samsung company want to know the exact reason why the sales is not good. So for that purpose, they contact these sources, Google search, online surveys, Facebook, Twitter, etc., and gather all the raw data from these sources. Okay. Why Google search? Because you know that people, if they want to buy some mobile, they'll go and do the Google search to find the reviews about their product, uh, about the product that they want to buy. Okay. Or else in Facebook they might be chatting with their friends. In Twitter also the same way. That is the reason they want to extract the data from these sources, and from all the raw data they'll filter out, they'll give these all the raw data as an input to the Hadoop. Hadoop will process and will give the clean output which contains only the reviews, list of reviews. Galaxy Grand, and what are its list of reviews. S3, what are its list of reviews. Okay, they got that clean output about the reviews only. Now they will take all that reviews and they'll find the positive reviews and negative reviews for all the models. Okay, using some programmer logic. Okay, so they were able to see that for Galaxy Grand there are more number of negative reviews, like it's it is not providing some good output for the camera, okay, or the internet is not up to the mark, it is very slow, 3G service is not good, okay, etc. So like that people keep sending some reviews about that particular model, okay. By seeing that, Samsung company higher management will decide that these are the areas, these are the features that needs to be improved, okay. From the Hadoop output we generate some reports and give to the higher management, and from that reports they will be able to identify what are the exact problems, okay. So Galaxy Grand has got these issues, this is the feedback that they got, okay. So they'll take that and they will try to improve the product features, and again they will do remarketing and resales. So that is how Samsung company is using Hadoop as one of the solution to process their data and improve their business, okay. And at the same time they are also providing some quality products to the customer. Customer is satisfied, company is also satisfied, okay. It's like a win-win situation, okay. So this is one of the scenario where huge data is involved and you want to process, okay, and make benefit out of it, fine. This is one example in the retail industry, okay, fine. So now what is Hadoop? Hadoop is an open source Apache project. It is from Apache company, okay, that enables the distributed processing of large datasets across clusters of commodity hardware. So whatever data you want to process, okay, whenever you give that input as that, whenever you give the data as input to Hadoop, it will distribute that data into multiple machines, okay, equally, and then will process that data on each and every machine in parallel, fine. So we'll see in detail, okay, as we go further in next slides we'll discuss about HDFS, so then you'll understand like more clearly, okay. So basically we distribute the data and process in parallel, that is what Hadoop does, okay. And then these are the Hadoop characteristics: scalability, cost effective, flexibility, fault tolerance. So first let us discuss about the scalability. So you need to understand why Hadoop has come into market, okay. So these are the some of the important features, okay, that is helping uh, users or developers to use Hadoop for their huge data processing: scalability, fault tolerance, high availability, huge volume. So before going to Hadoop, let us see like how these things are handled using RDBMS. What are the challenges in RDBMS and how Hadoop has overcome or how it is providing these features efficiently. First, scalability. If you take RDBMS means any RDBMS system, can be Oracle, MySQL, whatever it is. Let us assume Oracle. Okay. So RDBMS system, guys are able to hear me? Just can you please confirm on the questions window? Is my voice clear? So far clear, are you getting what I am discussing? Am I going fast or is it fine? Hi Kaival. Okay, fine. Thank you. Yeah. Okay, Digo. Fine. So scalability. So how scalability can be achieved using Hadoop? Before going with Hadoop, we'll discuss like what is the problem with scalability using RDBMS. Okay. So RDBMS, how does it process huge data? Okay. So you're having a system of capacity 1 terabyte. Okay. And your RDBMS is capable of processing that much amount of data, that is 1 terabyte of data, okay, fine, no problem. After 1 week your data is increased to 5 terabytes. Your data is increased to 5 terabytes. So what we need to increase? We have to increase our infrastructure. We have to increase our hard disk capacity, maybe to 6 terabytes. Okay. So this is your infrastructure. Just you can assume like hard disk. Okay. So you have to increase to 6 terabytes. Then only you can process 5 terabytes of data without any issues. 5 terabytes of data can be processed. So far fine. After 1 month, again your data has grown to 10 terabytes. Again what you have to do? You need to again increase your hard disk capacity. Like that, after a couple of months, your data is grown to some 100 terabytes. What will do? Again increase your infrastructure. That is hard disk capacity. Like that, you need to keep on increasing your hard disk capacity in order to process the amount of data that comes in as an input, which is a major challenge here, because always increasing your infrastructure, increasing your hard disk, and again resetting the things and again reprocessing is like a major challenge here. One day your system might become like a supercomputer. On a single computer, managing the whole data will become really a big challenge. Okay, so this is a problem with RDBMS, scalability problem. Okay, so this is what is called as vertical scaling. Yeah, you need to restart everything, you need to set up, reset everything. Okay, so vertical scalability means only increasing the infrastructure on that same machine to accommodate the amount of data that comes in as an input, and in order to process that, you just keep on increasing your infrastructure on that same machine, on that single machine. Okay, that is what is called vertical scalability. So this is what the challenge in RDBMS, and in Hadoop how we have overcome that. In Hadoop it is horizontal scalability. In Hadoop it is horizontal scalability. What does that mean is, so as I told you, in Hadoop the data is distributed across multiple machines. Okay, so if your data is grown, you can just simply add one more new machine. Okay, and you can accommodate the amount of data that you can process can be high without any issues. You need not touch the existing data or the existing infrastructure. You can just simply add one more node, one more machine to the cluster. Okay, so that is what the advantage with Hadoop. Okay, it can process X amount of data. X can be terabytes, petabytes, zettabytes, etc. without any disturbance to the existing data. Okay, so that is the advantage with Hadoop with respect to scalability feature. Okay, and then fault tolerance, high availability, huge volume. Okay, so these 3 points will be covering while we discuss HDFS. Okay, so before that, let me just discuss if you have any other points. Hadoop is written in Java. Hadoop is totally written in Java, and Hadoop core components are HDFS and MapReduce. HDFS and MapReduce. Okay. Yeah, Prabha. So, but the efficiency is still a problem, right? So you cannot keep on increasing the infrastructure. You need to do all the resetting and need to update many things. Okay, that is the not only the problem with RDBMS, but there are some other challenges also. Okay, we'll discuss. Just give me some time. So HDFS stands for Hadoop Distributed File System. Whatever data you want to process using Hadoop, that data first of all you have to bring and place in the HDFS. then only it can be processed, then only it can get the features of Hadoop. Okay, so once it is placed in HDFS, MapReduce or Pig or Hive, etc., can pick the data from HDFS and can process it and give the output. Okay, so these are the two core components, HDFS and MapReduce. Fine. Yeah, Shantanu is asking, do we need to have Java knowledge to learn to go for this Hadoop, Big Data Hadoop course? Yeah, you need to have some at least basic core Java knowledge. Okay, because MapReduce is mostly developed using Java only. Fine. So anyway, we'll have some couple of sessions on Java before we start on Hadoop. Okay. Core Java is fine, not entire Java, just core Java. In core Java also, few important concepts you need to know. Okay. I'll explore them. I'll just tell you them at the end of the demo session. What are the things that you need to have, like prerequisites. Okay. And Hadoop is useful for just batch processing. Okay. You can just process huge data. Okay. And then you can analyze the data. But it is not for online transactions. You cannot perform online transactions using Hadoop. Or its intention is not for that. Okay. Its intention is mainly for batch processing. And as I told you, Hadoop is created by which company? The main Hadoop project is developed by which company? Yeah, Apache. Apache is the main company which is working on the Hadoop project. Okay, and there are some other companies in the market like Cloudera. Do you have any idea what are the other companies that are providing Hadoop distributions? Cloudera, Hortonworks, yeah, Mapr, and there are some other companies also. They develop their own distributions and they use instead of using the existing API, okay, etc. So what these Cloudera, if you want to use Cloudera, the Cloudera's distribution is something like this: CDH3 or CDH4, CDH5 is the latest. Okay, CDH stands for Cloudera's distribution of Hadoop. Okay, so this is what we are going to discuss in our sessions, and this is what B is being mostly used in the real-time environments. Okay, Cloudera's distribution of Hadoop. It is also open source, and this Cloudera will take this Apache Hadoop and will do its own customizations, and it's if there are any additions it will add to the API, and they test it on thousands of nodes of cluster before releasing their distribution of Hadoop into the market. And also they are providing well good technical support to the companies who want to use Cloudera. We are having some certification programs, lot of stuff, lot of activities go with Cloudera. They are spending like dollars of millions of dollars on this Hadoop. Okay, fine. So these are the companies which are releasing their own distributions of Hadoop. You can use any of these. Okay, if but preferably go with any open sources. Okay, and history of Hadoop, little bit history of Hadoop. So Hadoop was inspired from Google concepts, Google file system and Google MapReduce. Okay, some around 15 years ago. Okay, in around 2000, Google has published some papers on Google file system. Their for their internal huge data processing, they have developed some Google file system and Google MapReduce for their distribution, for their parallel processing of their huge search data or whatever data it is. Okay, what they have done is they have developed them and they have published the white papers on those concepts, taking them as inspiration. The person called Duck Cutting, okay, currently is chief architect of Cloudera, who has created the Hadoop project. Okay, based on Google file system, he created HDFS, Hadoop distributed file system. Based on Google MapReduce, he has created Hadoop MapReduce. Okay, and the logo you are seeing, right? The logo of Hadoop, some elephant symbol. Okay, so it is actually named after his son's toy elephant. The name and the logo are named based on his son's toy elephant. And in 2009, the first experiment was done on Hadoop. Okay, so they tried to process around 500 GB of data in just 1 minute. Suppose you're having some employee data which is of 500 GB size, which are like 1 million employee records, 1 million employee data is there, and the requirement is to find the sum of the salaries of all the employees, all 1 million employees. Okay, so they were able to get that output, the sum of the salaries of all the employees, in just 1 minute. This is just one simple example to understand. Okay, so that is how they got to know the advantage of Hadoop, and from then Hadoop started being used in the market. From 2011 it has been started using extensively. Okay, Yahoo, Facebook, for their internal data processing they use this Hadoop. Okay, fine. Now let us discuss HDFS, and while we are discussing HDFS we will discuss about some of the important Hadoop features which are like challenges or limitations on other systems prior to Hadoop, like RDBMS or distributed systems. Just try to understand this Hadoop HDFS architecture or Hadoop cluster. Please try to understand this. If you are having any queries, just stop me here. So it's like a master slave architecture. If any questions, I'll take up. Just give me 2 minutes. Yeah, Varalakshmi, I'll tell on that point. Difference between distributed systems and Hadoop. Okay. So just let me give you some idea before going to Hadoop. Okay. So these are the systems. RDBMS you can use for huge processing, or distributed systems. Prior to Hadoop, these were the things, and then came Hadoop. There were some challenges and limitations in these two things, RDBMS, distributed systems, why we are using Hadoop. Okay, so among them we have discussed about scalability, and now we'll discuss other points. Okay, and we'll compare with earlier systems, how Hadoop processes and how earlier systems is processing the huge data. Fine. Just try to understand how the flow goes or how the data is processed. This is my HDFS architecture or Hadoop cluster. So this, let me say it as master, and these are my slaves. And on the master machine, so in Hadoop there are something called daemons, Hadoop daemons. So there are totally 5 daemons. So what is a daemon? Anyone? Any idea? What is a daemon? Anyone? It's like a background process. It's like a background process which runs your application or which runs your application. Okay, from background it will keep initiating okay, and it will run in the background. If you take your like Windows operating system, okay, if you want to run your MySQL in the background, there will be some service that is running and that keeps your MySQL running. They are something like a background processes which will actually trigger or initiate or keep your actual application running. Okay, similarly in Hadoop also we have something called these 5 daemons, okay, and which will make your Hadoop running. If these daemons are running means your Hadoop is running, then you can go ahead and you can store the data or you can process the data. Fine. And these daemons, name node, data node, secondary name node, are the 3 daemons that are responsible for data storage. The data that you want to process, first of all we store, it's taken care by name node, data node and secondary name node. And then data processing is taken care by job tracker and task tracker. Okay, so we'll discuss about this name node, data node, secondary name node as part of HDFS. And this job tracker and task tracker, they take care of data processing. Okay, so we can discuss about that while we are talking about MapReduce, because MapReduce is one of the component that will take care of data processing. Data storage is taken care by HDFS. MapReduce is one of the component. You can use Hive and Pig also. Okay, so now let us discuss about HDFS name node. So your name node, where it does, where that daemon runs is on the master. On the master, your name node runs. Name node daemon. Fine. And also your job tracker, JT. And on the slave node, you have data node. Data node, let us say it as data node 1. I'll just simply say DN. Okay, data node 1. This is data node 2. Data node 3. Data node 4. Fine. And you will have task tracker also on these machines. On the slave machine, you have data node and task tracker working together. And secondary name node you will have on a separate machine. Fine. So this is how your cluster looks like. And suppose I am having the data, some data which I want to store, emp.txt file, suppose which is of size 150 MB. Okay, and in Hadoop the default block size is 64 MB and default replication factor is equal to 3. Okay, so whenever you want to store emp.txt file in Hadoop, that is in HDFS, okay, so that you'll be issuing the request to the name node. The request first goes to the name node and name node will check all the data nodes, okay, which is having the hard disk space available. Okay, and for example this, so for 150 MB how many blocks are created? So the data is stored in the form of blocks in Hadoop. The data is stored in the form of blocks. Okay, and each block is of size 64 MB. Block is nothing but physical storage. Physically, the chunks are created from the actual input and they are distributed. The blocks are created on multiple data nodes. Okay, so if each block is of size 64 MB, for 150 MB how many blocks are created? Yeah, you will not have anything like a zero point 0.5, 2.5 something. You will, so three blocks are created actually. Okay, so like this three blocks are created. Block 1, block 2, I'm just using different color to indicate different blocks. For example, three blocks are created. Three blocks are created like this: B1, B2, B3, which if you combine, you will get the actual file 150 MB. Okay, and replication factor equal to 3. Replication factor equal to 3 means what? Actually, each block is created 3 times on the cluster. If you take block 1, which is green color, it is created 3 times on the cluster. It is decided by the framework where the copies must be created. It is not in the hands of the developer. It is present on D1, D2 and D3. And block 2 red color, which is present, there are 2 more copies that are created. And one more thing is, the same block cannot be on the replica cannot be on the same machine. The replica cannot be on the same machine. If once one block is created on a particular machine, the replica is created on another machine, the another data node, but not on the same data node. Okay, why what is the advantage of this replicas or replication? We'll see. And blue, the block 3, and the block 1 and block 2 are fully occupied, 64 MB plus 64 MB, and third block is not fully occupied. Okay, only 22 MB, 20 64 64, yeah, 22 MB is occupied. Okay, so the remaining space can be used by others. It's not that it is not blocked by this block. Okay, so like this the blocks are created, 3 copies are created for each block. Basically what does that mean? This emp.txt is available as 3 copies in the cluster. emp.txt is available as 3 copies in the cluster. Okay, Ramreddy, can you tell me for 150 MB file how many blocks can be created? See, one record, I did not say one record is 150 MB. The total file size is 150, I said. The total file size of emp.txt to store on the hard disk is 150 MB. But while storing in HDFS, it is stored in a different way like this. It is stored in the form of blocks like this. Okay. And as the size of block is 64 MB by default, you can increase also of course. Okay. But by default it is 64 MB. So you can see like this 150. If you want to have accommodate all the 150 MB on the cluster, 64 plus 22. You need 3 blocks. So that is how we created 3 blocks: green, blue and red. Okay, like this blocks are created on different machines. This is not in our control. Framework will check where the space is available, where the disk is available and create the blocks on that particular disk. on that particular data nodes. Okay. From now I'll say I'll use data node as interchangeably with slave and name node interchangeably with master. Okay. So this is how the data is stored. Fine. So far fine. Any queries? See, data node is not having 64 MB, more than 64 MB. The hard disk of each and every data node, okay, so is occupied by these blocks. On the hard disk of each of these data nodes, we are creating these blocks. Might be on data node 2, the hard disk capacity is more. I mean, like the availability of the disk is more compared to other data nodes. Clear? Yeah, I'll tell. So data nodes is, let me tell you now. This is how the data is stored. Now tell me, now let you know the what is the role of name node and what is the role of data nodes. Okay, name node will store only the metadata. It will just take care of metadata. Name node will just take care of metadata. What is metadata means? The file that you want to store, here in our case emp.txt, replication factor, create date, okay, etc. Along with that, for that given file, for that emp.txt, what all the blocks are created? Block 1, 3 blocks are created for us. Okay, let me name like this. So the green block, let us say it as B1, red as B2, blue as B3. Okay, so like that we have 3 blocks. Okay, and can you tell me where block 1 is present? On which data nodes block 1 is present? On which data nodes block 1 is present? Data node 1, 2 and 3, right? Fine. Where block 2 is present? 1, 2 and 4. Yeah. Where block 3 is present? Block 3 is blue. Blue is present on 2, 3, 4, right? Fine, so far clear. And this is what is called metadata. And this is what is taken care by name node. Name node will just take care of metadata. And the actual data storage is taken care by data nodes. Okay, the blocks are created on the data nodes. Okay, and name node will just take care of this metadata. And this metadata is stored in the form of 2 files. Okay, there are 2 files called edit logs and fs image. So this entire metadata is stored in these 2 files. Okay, so let us not go in detail about these files as of now. So these are the 2 files that are used to store this metadata. Okay, fine. So now name node knows for a given file where all its blocks are present, on which all data nodes the data is present. If someone wants to read emp.txt, they'll issue a read request to name node. Then name node will go to metadata and it will check for that file what are the blocks are available and on which data nodes they are present. This information is provided to the client and then client will go and read the data from the data nodes. That is how the flow goes. Fine, with respect to read and write operations. And one more thing is, there is something called heartbeats. There is something called heartbeats. There is something called heartbeats that is sent from data nodes to the name node for every couple of seconds, 3 to 5 seconds, if it is like a small size cluster. Okay. And if there is no heartbeat for some time, for some amount of time, there is no heartbeat from data node to name node. Okay. Fine. So if there is no heartbeat from a particular data node, name node will assume that that data node is gone down. After 10 to 15 seconds also, suppose there is no heartbeat from data node 1. There is no heartbeat from data node 1. Okay. Then my name node will assume data node 1 is gone down. If data node 1 is gone down, your process will be stopped or it can continue. Your process is stopped totally or it will be continued. And how? It will continue. Because, why? Yes, excellent. Because we are already having replicas. Okay. Suppose even though this data node 1 is gone down, okay, still you are having the block 1 available on data node 2 and 3. Block 2 available on 2 and 4. Block 3 available on 3 and 4. So my name node will pick any one of these blocks from other data nodes and will continue to process without any stoppage. This is the advantage of replication management. This is the advantage of the replication management, which is what the important feature of Hadoop, which is fault tolerance and high availability. Fault tolerance means even though if there are any faults in your system, still your system is able to continue the process. Highly available is in the sense, even though if your data node is gone down, still your system is available for processing the data because of its replicas. Fine, clear? So if you compare this with your distributed systems, okay, so in distributed systems there is no such efficient communication between your master and slave. Okay, so your master does not know for a long time if your slave is gone down or not. Only it will be able to identify if it is taking lot of time to process the data. Physically or manually you need to go and check if there is any problem in the slave. If yes, it should be replaced manually. And again the data present on that machine should be again reloaded and again reprocessed. Okay, so that is a challenge with distributed systems. But here in case of Hadoop, we are having some efficient way of communication between master and slaves. And because of these replicas, we are able to achieve fault tolerance and high availability of the data nodes. Okay, Krunal, now you got the point why we are creating multiple blocks, replicas. This is the reason. This is how to achieve few features, important features. While processing huge data, these are the important features that are required. Okay, clear now, Krunal? Yeah, that should not be a problem because we are dealing with huge data sets. You'll have a lot of hard disk capacity for each and every data node. And this number 3 is the ideal. After a lot of research, lot of experiments, they came to this conclusion. You can increase that replication factor or decrease that. Okay, but 3 is the ideal number. Fine. And this is the advantage of replicas. Frequency of heartbeat is like it's like 3 to 5 seconds. Okay. If your cluster size is more, your name node will take some more time to receive the heartbeat. Okay. Digo, what is your question? You want question of what? Which question? Please repeat question. I did not get your point. Okay, okay, fine. Yeah. I mean, like Kronal asked, like, what is the use of these replicas? Too much space is wasted. So I told the reasons, right? To achieve fault tolerance and high availability, the replicas were created. Fine. Is the extraction based on key value pair? Yeah. For reading the data from these blocks, okay. So there will be something called MapReduce program running on each and every machine. Okay. The MapReduce program that keeps running on each and every machine. For this MapReduce program, the input for this MapReduce program on data node 1 is these blocks. These blocks will be the input. And from these blocks of data, key value pairs are prepared by record reader and they are given to the MapReduce program. Okay, we'll discuss in detail while we discuss about MapReduce. Okay, but as of now, just remember, yes, from these blocks, key value pairs are prepared and given to the MapReduce. Fine, yes. Clear? This is what HDFS is about. Any queries here? I think from this you can tell that using Hadoop we can achieve high availability. But whereas in case of RDBMS you cannot say the system is highly available. All the data is resided on a single machine. When that machine goes down, that's it. Again you need to restart or reprocess. Okay, you have to first make the system up. Again you need to reprocess. If you are processing huge data, then it will become a headache. Again to start from scratch. Okay. And also fault tolerance, so which is the important feature of Hadoop, okay, which the distributed systems are not able to provide efficiently. Okay, clear? So these are the some of the important features of Hadoop. So I'll stop here and let me tell you like what are the other ecosystem components. So that is about HDFS, and these are the other ecosystem components: HBase, Pig, Hive. You can use any of them and you can process the data. They have their own query languages, they have their own scripting languages using which we write like various queries and we process the data. Okay, there are some differences between each of these components, we'll discuss in detail, okay, in our full-time sessions. Okay, whereas Hadoop MapReduce can process any kind of data, structured, semi-structured, unstructured, but whereas Pig or Hive, they are best suited for processing structured data. Okay, and Scoop is a tool, it's like an import or export tool. If you are having some data in RDBMS, okay, I mean like I want to migrate my solution to Hadoop. So to import that table data from RDBMS systems to HDFS, we use Scoop. Okay, we can import the data or also we can export HDFS to RDBMS also using Scoop. Fine. And Uzi is like a scheduler, job scheduler. We can schedule the jobs. We can schedule MapReduce jobs, Hive jobs, when they want to run, when you want to run. Something like a cron jobs in your Linux or Unix environments. You cron the job, right? For every 1 hour, I want to run so and so job. Like that, you can configure in the Uzi. Okay, this is part of Hadoop ecosystem. Fine. So these are the important components. Okay, which we will be covering all these components. Okay, as part of our sessions. Fine. And these are the various industries. Retail industry, we have seen one example. Okay, retail stores, Walmart. Okay, online shopping sites like in online shopping you can use Hadoop to process its huge data. Okay, so these are some of the industries. Let me show you. eBay, I think you know eBay, right? It's like an online shopping portal. It will have huge data in the background. Okay, so the customer transaction data, about the products data. Okay, that all data if you want to process you need Hadoop like a solution. Fine. And in telecom domain, customer churn prevention, calling data record analysis. Okay, calling data record in the sense millions of users will be using this service provider. Here it is China Mobile. So calling data record will have information about the user calls, to where they have called, source, destination, how much time they have spoken. Okay, so etc details. So they can take all that data and they can do some analysis, and out of that analysis they can find that people are showing interest or people using the service during these times, during night hours they are using the service more efficiently. So provide users some benefits during that time, provide some extra minutes, provide some extra packages. Okay, so out of the analysis they can come to that conclusion, thereby they are not churning out their customers, they are holding their customers without going to other service provider. Okay, so like that you're having like various examples in financial finance industry, retail industry like seeds company. Okay, in healthcare domain, government sectors. Okay, so these are some of the examples. Okay, some of the industries where you can, where big data is present and you want to use Hadoop as one of the solution to process weather reports, insurance sector, social media. Fine. Okay, so these are the industries where huge data is there and I want to use Hadoop to process that huge data. Okay, so this is about the demonstration, guys, and just let me tell you the training plan. Any advantages of the cron job? Advantage in the sense you can cron the job. That means I want to run the job for every hour. Instead of running manually, I'll cron it so that automatically it will run for every 1 hour. That is what cronning in Unix or Linux environments. The same concept we can do, same thing we can do in using Uzi in Hadoop. Okay, fine, Varalakshmi. So these are the core Java concepts that you must be aware of. Any advantages of Uzi compared to the cron job? Yeah, you're having a lot of features in Uzi. Okay, I'll just tell you them. Okay, while we discuss about Uzi, yeah, some many features in Uzi. Okay, so these are the important concepts you must be aware of. Okay, basic core Java stuff, modifiers, data types, wrapper classes, OOPS, object oriented programming, collections and generics. Okay, exception handling, string API, file IO. Okay, so these are the important concepts. At least you must be aware of. Even non-Java folks must be aware of. Okay, in order to start up with MapReduce. Okay, Linux knowledge. Just if you have idea on the commands, basic commands, that should be fine. Unix or Linux commands. Okay, even though if you are not aware, that should not be a problem. Fine, but just go through the commands at least. Basic commands and SQL. I think many of them know about SQL, right? Basic SQL queries. If you're aware, that should be fine. So these are like prerequisites one should know, okay, before going with Hadoop. Anyway, we'll be covering this Java part as part of our session. SQL you might be aware of. If not, you can just go through these basic SQL commands, okay, and then Unix commands. Anyway, we'll be discussing about HDFS commands, okay. So if you go through these Unix commands, that would be like more useful for you. Fine. And this is the training plan. So we'll be covering these topics as part of our Hadoop course. Introduction to Hadoop and about HDFS. MapReduce basics, MapReduce advanced concepts. Hive, Pig, Scoop, Flume, Uzi, and I'll give you some overview on Hadoop 2.x, which is the latest version, and about Yarn, which is MapReduce version 2. And we'll see one small sample case study, and we'll discuss some real-time environment or how the Hadoop project is implemented. Okay, and these are the prerequisites. So these concepts, both theory and practicals, will be covering. I'll be showing some online live examples. I'll execute and show you. I'll provide you some assignments. Okay. So that is how the course goes. Fine. And these are the prerequisites, and these are the softwares I'll be providing. Cloudera, VMware, and VMware Player. Okay. So as part of the course, I will be providing you all the documentation. So course is covered with both theory plus practicals, and also some assignments I'll be providing you. You can practice. I'll be providing all this documentation which I'm going to discuss in the session. For each and every session, we'll be having a video recording. Okay, will be shared within 24 hours. Okay, and all the necessary files, necessary documents, necessary input files for each and every topic. For MapReduce, for pig or hive, whatever input files are required, I'll be providing so that you can practice. Fine. So this is how the course goes, and the course will be of around 5 to 5 weekends. Fine. And it will be from Sunday to Thursday, same time, today's time, 6 p.m. Fine. It will be like 1 hour session daily. Clear? Clear, guys? Any queries? So I'm done with my demo session. Okay. If I'll be parking for another 5 minutes. If you have any queries, let me know. Prabha, it depends on the data you want to process. Okay. Uh, whereas Cassandra and MongoDB are NoSQL databases. Okay. Whereas Hadoop is a batch processing system. Varlakshmi, what time will it be? Means the same time, today's time, 6 p.m. for 1 hour, and it will be for around 5 and a half, hopefully 5 and a half weeks, or at the max 6.